Most important, this speaker series is supported through an endowment by the Carlos and Andrea Alberini Family Foundation, which brings renowned innovators and thinkers in design to campus to inspire students and encourage community engagement and learning. It would be hard to overstate to the Alberini family how meaningful this speaker series is to the intellectual life of our department and its students. Thank you so much. It's my honor to invite the Chancellor of UC Davis, Gary S. May, to open this afternoon's event. Chancellor May earned his master's and PhD degrees in electrical engineering and computer science at UC Berkeley, and is a member of the National Academy of Engineering and the American Academy of Arts and Sciences. His vision as UC Davis's 7th Chancellor is to lead the university to new heights in academic excellence, inclusion, public service, and upward mobility for students from all backgrounds. Please welcome Chancellor Gary S. May.
Thank you, Simon. On behalf of UC Davis, I'd like to welcome everyone to the Alberini Family Speaker Series in Design. This series brings the most influential and cutting-edge designers to campus and provides meaningful interactions with students. It fosters dialogue and learning with thought leaders while engaging the public in a greater understanding of the aesthetic and functional importance of design. These leaders in design are a great source of inspiration for students. They encourage our students to think of different ways of thinking and working. They inspire students to create dialogue, to furthering ideas, and help them stay current in the wider world of design. The Speaker Series increases awareness of the excellence of the UC Davis Design Program, both nationally and globally. It enhances our faculty's influence on the field of design and the value of our alumni degrees. The series is comprised of a public lecture and multiple student components. They include participation in an ongoing design class, graduate student critiques, and opportunities for informal networking. Bringing in high-profile speakers like today's guest provides an opportunity for the Department of Design to align itself with all of the publicity generated by these new activities. It also presents the depth and reach of design in a comprehensive manner. In all, the UC Davis Department of Design is redefining what's possible through the power of innovation and collaboration. This is the only comprehensive academic design unit in the UC system. Their mission is to change the world for the better. That mission is integrated into everything they do, with a curriculum that spans visual communications, sustainable design, writing, and interior architecture. They offer a creative and flexible approach to the study of design. They do it with an emphasis on socially responsible, human-centered, and sustainable practice. Today's speaker, Julia Koerner, is the 5th speaker in this series, which is funded by the Alberini Family Endowment. Andrea Alberini is a UC Davis trustee whose daughter, Alexis, is a 2016 graduate of the UC Davis Design Department. We are all grateful to the Alberini family for funding this impactful lecture series. With her focus on sustainable practice, the Design Department invited Julia Koerner, an acclaimed designer whose work intersects with architecture, product, and fashion design. Julia is an award-winning Austrian designer, the founder of JK Design GmbH, and an adjunct professor at UCLA. We are particularly excited that her recent collaborations include 3D printed haute couture and the Academy Award-winning costumes for Black Panther, one of my personal favorite films in the Marvel Cinematic Universe. Julia's work aligns perfectly with the UC Davis Design Department's focus on sustainability. Her lecture, Models and Models, will focus on recent innovations in 3D printing. These have revolutionized the cross-disciplinary design work of architects and fashion designers by changing traditional craftsmanship and spurring innovation. These new methods reform fashion production and potentially reduce shipping, carbon footprint, and textile waste. They also open up opportunities for implementing sustainable processes in production, along with showcasing innovative new aesthetics. We anticipate the discussion will be lively and engaged on how these sustainable practices can impact the design work of architects and fashion designers alike. This is a brave new world of design, and UC Davis is helping to lead the conversation. Thank you for joining us.
And I'd like to introduce our speaker for this afternoon, Professor Julia Koerner, a highly acclaimed Austrian designer and founder of JK Design. Her work intersects with architecture, product and fashion design, and she is internationally recognized for digital design in 3D printing. And I should add, I've just been talking to Julia, and she really has gone the extra mile for us. She is joining us today from Jordan. And I think it's in the early hours of the morning. Julia received master's degrees in architecture from the University of Applied Arts in Vienna and the Architectural Association in London. She previously held academic appointments at the University of Applied Arts in Vienna, at Lund University in Sweden, and at the Architectural Association visiting schools in France and Jordan. She is a faculty member in the Architecture and Urban Design Department at UCLA, where she's the director of summer programs. Her designs have been featured in the National Geographic magazine, Vice, Wired, and the New York Times, among other publications. In 2019, Arconnect named Julia Architecture's Queen of 3D Fabrication. Her work has been exhibited at the Metropolitan Museum of Art in New York, the Art Institute of Chicago, the High Museum in Atlanta, the Philadelphia Museum of Art, the Palais des Beaux-Arts in Brussels, and Ars Electronica, among other venues. You know, we couldn't be hosting a more inspiring speaker as we look forward to returning to campus and making things together again. While we've been away, the Department of Design has been transformed with the completion of a new makerspace, developed with the spectacularly generous support of Giacomo Marini and of the Marini Foundation. The makerspace includes an open lab for project critiques, a metal shop, a wood shop, prototyping classroom, and MFA graduate students and undergraduate students in industrial design, wearable tech, and prototyping classes have already been 3D printing and laser cutting this year, thanks to the work of our TAs, design staff, and above and beyond supervision by some of my colleagues. And I think that's my kind of entree to prepare to be transported now by Julia's work and to imagine the futures made possible through technological change in design. Today's lecture will be followed by a Q&A, to which we warmly invite you by writing questions in the box on Zoom during and after Julia's talk. So if you look, there is actually a Q&A box. I think maybe the chat is open as well, but there's a Q&A box if you want to pop questions in there, and Julia will hopefully be able to answer them after the talk. So with that, I'm going to turn proceedings over to Julia. Thank you, Julia.
Thank you, Simon, for the great introduction. I'm going to share my screen. Thank you so much for the invitation for this great lecture. And I'm very happy to join, as Simon mentioned, from Jordan. As the date came closer, I was moving every time further away, it seemed to me, first Austria and now in Jordan. And I look forward to returning to Los Angeles quite soon. I'm very happy to speak at UC Davis today. And I would like to introduce myself. So I'm Julia Koerner, and I'm the founder and director of JK Design GmbH in Austria, Salzburg, and the co-founder of JK LA LLC with my partner and husband, Kaisal Ravi. And I'm an adjunct assistant professor at UCLA in the Architecture and Urban Design Department, where I'm also the director of the summer programs. My work bridges between multiple scales. I'm trained as an architect, and I work between architectural installations, product design, and fashion design. Most recently, also more and more in the costume design industry. Today's talk is called Models and Models, and I want to talk more about inspirational personalities which kind of worked with me along my path, and inspiring female people who have inspired me along my way. First of all, I'm really inspired by Charles and Ray Eames and their kind of philosophy behind their practice, inspired by nature and practicing in architecture. While my studies at the University of Applied Arts in Vienna, where I was studying with Greg Lynn, I was also fortunate to be next to the studio, which was taught by Zaha Hadid, one of the most inspiring architects I ever met in my life, and who has really led a great path for young architects like me to have an aspirational model to kind of follow along. Coco Chanel has been always a huge inspiration for me. I was always in between fashion and architecture, interested in both paths. Little did I know that I studied architecture in order to later on return to work within the fashion industry and to even have the opportunity to work with high-end fashion brands in Paris and to kind of cross-bridge the disciplines between architecture, fashion, and product design. Models such as Amy Mullins, who have been groundbreaking in their kind of paradigm change of looking at how humans are perceived with disabilities and how the kind of superhuman enticement can be embraced. I made this also part of my thesis at the University of Applied Arts. The human anatomy and its body and its space surrounding it was always something which I was very interested from early on. And Greg Lynn, who was my professor in Vienna, who brought me to UCLA, who I was teaching together with at the Super Studio, which is a post-professional degree. When I first time saw the embryological house in Switzerland in an exhibition, I knew I really wanted to study with him, and he kind of opened a lot of opportunities for me. And I think these kind of role models are one part of my experience, which led me to where I am today. But on the other hand, also models can be seen as like physical models, models as models in the fashion world, figures which represent the fashion items which I design, and also in the architectural disciplines. In my design, I look a lot at the kind of convergence between nature and the implementation of organic design language. And I'm inspired by what you can find in the various different body parts inside and outside, and the human anatomy is kind of embedded within an aesthetical language I developed over the past 15 years. Here, for example, you can see a case for an artificial knee. This was a case study which I did as a student, but I show this because it kind of shows my early interest in the kind of relationship between muscles and bones, and how this kind of organic formations and morphologies have led itself into the development of then later on designing architectural spaces or enticing products. In my thesis, inspired by Amy Mullins, I designed a biomechatronic research center in Manhattan, where I looked at the idea of taking the kind of development of prosthetics outside of a hospital, of a basement, up into a showroom, and kind of showing what opportunities and possibilities you can have and how you can kind of implement superhuman enticement into this kind of paradigm change. For anyone who doesn't know who Amy Mullins is, she was born as an amputee, and she kind of modeled for a lot of different fashion brands in the early 90s, where she, in 2000, where she kind of had the ability to be one of the tallest models on the catwalks, because she had made herself shoes and fashion items which kind of enticed her, and she had abilities which others didn't have. And I thought this was a really inspiring opportunity. And especially with 3D printing and emergent technologies, I looked in how we with architecture can embrace such a place and design a kind of futuristic place where something like this could occur. In architecture, we use 3D printing to create physical models. So what you can see here is a small scale powder printed physical model. And at an early time at the Angewandte, around 2005, the school had their first 3D printer. And I thought this was a really exciting moment, because I could kind of visualize not only on the computer, but I could make my ideas tangible. And I was very interested in this output back and forth between the digital and the physical environment. And so I implemented these kind of learning experiences and often errors which I received in those physical models into the procedure of my design processes. While I was a student already, I got the opportunity to work with Ross Lovegrove, an industrial designer based in London. And so I started to kind of be between London and Vienna, go back and forth. And I worked with him on many product design projects where we looked into how can we bring the architectural design processes and parametric design and generative design modeling techniques into product design. This was a light what we designed for Artemida, which was supposed to reflect the light in different nuances and directions. But it was not only an aesthetical approach, it was also how can we utilize inexpensive fabrication techniques such as thermoforming in order to create large-scale lightning sculptures. But also how can we utilize 3D printing and injection molding in order to produce a larger series of elements for this chandelier, for example. Another light design what I developed with Ross is the new nature light, also for Artemida. In this case, we looked into how can we optimize an injection molding process, because injection molding is quite expensive. You have to invest in one mold. So the repetition in the mass production is quite recognizable. And in this slide, we looked at how to make a column out of 16 parts while there is no repetition essentially visible, and it doesn't look anymore like as a repetition of 16 elements. And we used 3D printing in this as a method of kind of understanding how we can make one single mold for one part, which is then flipped around, mirrored, and kind of implemented into over the whole light. And we also looked into the various different shading principles and lighting to the inside of the core of the light. And please keep this product in mind because I'm going to come back to it at the end of my talk later on. So remember this project. Around 2010, I got the opportunity to do the Max Schindler Scholarship. It's from the Museum of Applied Arts in Vienna, an international scholarship to go for 6 months to Los Angeles and live in one of Rudolf Schindler's case study houses, in the Mackey apartments in this case, where for 6 months I researched the biodiversity of California. It was my first time in California, and I went to all the different national parks and took the opportunity to create more than 2,000 photographs and a lot of different videos of the various different biodiversities and all the patterns which you can find in nature. And I realized that I'm not only interested in the aesthetic and the kind of biomimicry of those forms and shapes, I more and more was interested in the mathematical underlying logic of those. So I realized I really wanted to understand how can I create such structures and formations with the computer. And so I decided to go back to London and do another master degree in architecture, especially in emergent technologies and design at the AA. That's also around that time I started to utilize 3D scanning, and I started with laser scanning and then later on with CT scanning, computed tomography, where I looked into, for example, corals and how their internal porosity levels can be captured with those scanning techniques. So not only the exterior can be scanned, but also the interior. And the reason I was interested in that was because I really wanted to understand how can this underlying beauty, what we find in natural formations, can be implemented into design processes. And so understanding those mathematical logics led me to not only be able to learn how to 3D model such systems, but also how to make those tangible. And so I continued with my 3D printing processes I learned earlier at the Angewandte and had the chance to grow at Ross Lovegrove, but I also kind of looked into scripting methods and how to write code. This was a collaborative project with Marie Boltenstern and Kaisel Rabi where we started to look how we can set up a simple script, or simple, actually a quite complex script, but which can read certain parameters and then change according to those inputs and parameters. So in this case, how can you change the porosity over a certain surface so that it can adapt to different levels of density and openings and apertures and so forth. And you no longer have to repetitively model everything physically, but you kind of generatively develop a process where you can automate that. And we then implemented that in various different projects. This was a facade prototype for the Acadia conference in Canada in 2013, where we were finalists for a competition called TextFab. And we plasma cut and fabricated that facade prototype robotically. And then it was very labor intensive because it had a lot of screws in it. And it was very, took a lot of time to kind of put it all together. As we then developed this kind of cellular complexity project further, we won a competition for which was done through the AIA Los Angeles, and it was an exhibition design for the Architecture and Design Museum in Los Angeles. It was supposed to host the 32 best student projects exhibited for 32 best student projects of California in architecture. And so we really wanted to kind of move away from this labor intensive screws and bolts. And we developed a CNC fabricated structure, which didn't have any adhesive and screws in there. So it was a push and plug system, which had numbers at each of these joints, and was able to be put together and taken apart. It was CNC machined out of a material called Sintra, an expanded PVC. And we kind of had a limitation in the budget. So it took us a while to find somebody, a sponsor, who was able to actually fabricate all of those panels. And it was Sabic fabricator who usually also machines Boeing airplane windows. And they at the beginning said, yes, sure, we can fabricate everything. When they realized how many bits and pieces and panels we had, we kind of challenged their technology on every end. And that is something which is really core to any project I really do. I kind of naturally always push the boundaries of what can be done with it. And it's also something which inspires me and motivates me, how we can kind of push boundaries of existing methods and techniques. Because it's a project which can be disassembled and reassembled, we decided to exhibit this installation also in Jordan at the Amman Design Week in 2017. You can see here in the front my partner and the Queen of Jordan, where he's kind of explaining the project. But the most fascinating thing is that the entire structure fits into a 2x2x2 crate and can be shipped and placed at other locations. And so this kind of idea of reusing installations and kind of thinking about the afterlife of such installations is something which I really think is important as designers, that we kind of think about what the purpose of these designs are in the future and how we can reuse them or deploy them in other ways and methods. It was not the only time that we participated in the Amman Design Week. It's a kind of great platform where young designers, architects, and artists can show their work. And we did something in 2019 as well, where we looked at the kind of column capitals of Petra. Petra is this carved city, Nabatean city in Jordan, where you can see here in the images, the columns have been eroded over hundreds of years, and these kind of morphologies are still recognizable in the stone, and kind of next to each other you can see columns which have not been eroded, and then areas where it's totally eroded, and you can see how nature kind of takes over time. And we use that as an inspiration to create a grid of 25 column capitals, and the project was called Column and Crowns. And this idea came also because it was shortly after the costume design for Black Panther, where we looked a lot into the design of crowns, and we realized that there are similarities between the crowns and the capitals of the columns, and so we kind of investigated that in a kind of formal approach of this series. We took this research even further and developed over the last year 2 public art sculptures in Santa Monica. They are entirely 3D printed in our own studio printers. The reason I'm mentioning this is because at the beginning, when we got the opportunity to design those public art sculptures, we thought of an entirely different fabrication process. We thought we would CNC machine them. And the reason for that was because we simply didn't have enough budget to outsource the 3D printing to a company to print it at such large scale, because 3D printing is still a very expensive technology. And then the pandemic started last spring, and we kind of were forced, because all the shops and fabrication shops closed, we didn't have the opportunity anymore to kind of CNC it. And so we said, well, but we still need to kind of realize those objects. And then my partner and I, we started and investigate how could we actually print those on our own printers. And so we figured out the method that we could actually print it without any support material. So it's extremely lightweight. What you see here is about 3 millimeters thickness of a filament being laid up. You can see on the left a full print almost at 80%. I put this in there because someone might ask, how long does something like this take? So this is about a quarter of one of those columns. You can see here, it has 22 hours left. It already printed 130 hours. So it actually took us around 2 months to print both of those columns. Some of those prints took 5 days. And there were also errors in there. So sometimes I would come to the studio after 5 days and I would see like the entire print was not working. It was a learning process, but a really kind of interesting one. And I think especially throughout the pandemic, we looked more and more about in-house 3D printing. And one of the projects which was a result of that was also the tutu, which I designed for the Bulltub showroom in Beverly Hills. It's a fashion item which we are currently working on with a performance artist, also from UCLA. And she will be wearing it and kind of make a performance in this tutu, and we are producing a video right now on that. Furthermore, I designed very recently an award design trophy where I looked into plant-based materials. So this is a new technology which we are looking at, where we can 3D print with materials which are made out of corn. And we are looking at this because I have a desire to kind of really push the 3D printing further with not only biodegradable materials, but also with materials which are using considerate resources. And so these plant-based materials are really fascinating because they are kind of deviating away from other materials I have 3D printed in the past with. And this is quite powerful, this technology. And this is a very recent project I wanted to share with you today. Another very current project I'm working on with Solaris Community, a startup in Scandinavia. They have developed a process where they are recycling ocean waste plastic, which they are collecting in Thailand, and they are creating it into filament where you can 3D print with. This is an ongoing project where I look into how you can utilize that printing material for a design of a light project. I cannot show more at the moment, but this is something which is ongoing in the studio right now. During the pandemic, I also started to look more into local collaborations. And so I did a very interesting project with a glass-blowing artist. Her name is Austin Fields. And the project was initiated by the Austrian consulate and Open Austria in San Francisco, where they kind of looked for collaborations between Austrian artists and US-based artists to kind of support them throughout the early stages of the spring 2020 of the pandemic. And so we looked into kind of a work process, a virtual work process, where I would design 3D printed molds, which then Austin would take and make plaster molds of, and she would blow glass on top of those 3D printed objects. And this was a really great project because it was the first time that I actually worked with an artist who was in the same city as I, but we couldn't meet because of the virtual environment. And we tried to really see how could we do something physical, something tangible, which was not only based on virtual environment. And we never actually met, but we kind of brought these two materials of the glass and the 3D printing together and created a series of 10, 15 objects throughout this project. In the next part of my lecture, I want to talk more about cross-disciplinary design processes and how recent innovations in 3D printing materials such as laser sintering, stereolithography technology, and so forth have revolutionized the cross-disciplinary design work of architects. So around, I would say 10 years ago, there was a really interesting time right when I was at Boss Lovegrove. I started to work with 3D printing companies and got very well connected with the various different technologies which were out there at the time. And so I looked into the micro scale of what you can do with those technologies, because obviously it was an early stage, so you couldn't yet 3D print on an architectural scale. And I thought that the human body was an immediate scale where you could, at that kind of resolution, print with very high-end printers. And there was one particular project where I looked into the deep sea sponge and its structure and makeup. And I developed a dress which had this kind of microstructure scripted into it so that the dress essentially would look like it's grown around the human body. It also had biodegradable elements in there, which had a thermochromatic pigment. So it would change from black to white, depending on the temperature of the human. And so the dress was meant to kind of showcase the mood of the wearer, or showcase its expression and temperature change. You can see the elements here soon in, and I think I have a video which kind of showcases the process.
Printing is transforming the fashion industry, revolutionizing the materials available and the design process. I've created a dress that reflects the mood of its wearer, made from a fabric that responds to temperature and touch, making the garment completely personalized to the individual. I was inspired by the natural world especially, and how organic fibers react to their environments. So my process begins by 3D scanning living organisms, in this case a sea sponge, to understand its structural makeup and properties. I then use this as a starting point to design and craft a garment. Scanning the wearer creates a 3D model of their body, giving me a basis to design the different structural properties, thickness, flexibility, rigidity of each part of the dress. Next, I incorporate the responsive materials that help the dress respond to light and temperature. With these advances in technology, it's becoming easier to imagine a future where clothing is completely personalized to the individual. Not just in how it looks, but also how it responds to your physiology and environment.
So So similar, like in this project where I was inspired by the deep sea sponge, in a lot of my work, I'm inspired by natural elements such as also kelp, for example. So one day I was walking in Malibu and I found this really beautiful dried kelp elements, which were frozen in their kind of liquid organic shape. And I took them home and I 3D printed them and I kind of used those as a digital mold to model over them and to kind of generate morphologies. And then I developed this 3D printed jacket, which was a collaboration with Stratasys and was one of my first ready-to-wear collections in 2015. And we worked with a polyjet technology, which utilizes a flat bed where you can print on. And what you can see also here, there was still a lot of support material, what we used in this printing process. Obviously, that creates a lot of waste material. And since additive manufacturing is essentially a process where you only need to use that material, what really you want to use in the product, since I would say in the last 6 years, I have more and more focused on how can you design without using any support material. So you literally only use that material, what you want to have in your design. And I have more visuals for that later. That was the Sporophyte Collection. I organized a photo shoot with an Austrian photographer at the James Goldstein house. I knew James from my architecture students, where I took them several times to the John Lautner house and gave tours there. And so I reached out to him and said, wouldn't it be amazing to shoot the first 3D printed ready-to-wear collection at his house? And he said yes, and that was really exciting to kind of get this opportunity to do it there. And it was later on published in Schön magazine as an editorial. And so a part of this Sporophyte collection was also the Humanium Jacket. That one was inspired by the underside of a portobello mushroom. And I looked at these kind of lamellas and undulating surfaces and developed this flexible jacket. This is a recurring pattern which has been part of several different designs up until today. And I kind of turned back to this pattern a lot in a lot of my projects, even up until today. Also here you can see the printing process. You can see that the white material essentially was used as supporting structure. This was one of the first 3D prints I did with this technology. Meanwhile, I'm going to show you in the Haute jacket, I have created designs which don't need those kind of support materials anymore. In the Iceland collection around 2017, I thought it was my desire to kind of make less of jackets and larger garments, but make it more accessible and look at kind of smaller scale accessories and handbags and necklaces. And so I started to design smaller scale pieces. Often, for example, like the one on the right, you can see the dimensions and the cuts were inspired by the bounding box of the 3D printer rather than essentially a cutting pattern from a kind of pattern making perspective. So the boundary of the 3D printer would kind of determine how large I could make a garment. And I also started to combine it with other fabrics and stitched it on traditional fabrics and combined it with buttons and so forth to kind of look into the combination of traditional craftsmanship and innovative novel technologies. I took the Humanium pattern and developed one of the first Humanium bags. This one was printed in-house on our own printer with a biodegradable FDM printing process, biodegradable PLA material. And in the meanwhile, we have developed this handbag further, and we will launch it soon as a kind of new brand, not a new brand, a new product, which is printed also with the plant-based material. In 2019, I had the chance to exhibit and showcase some of the Iceland collection pieces which were acquired by Google at and they showed it at their I/O conference with a new AI app. So you can see on the bottom, for example, an image On the left, you see the real model with the handbag and the necklace. On the right, you can see the kind of augmented reality filter showing the virtual model next to it. And it kind of came in handy because my designs were already existing as three-dimensional files. So this was a great opportunity to kind of show the work in a different framework. I want to talk a little bit more about recent developments in the 3D printing. As what you will see is that in the early stages, a lot of the designs were rather rigid and less flexible. In 2019, I got the opportunity to collaborate with Stratasys again on this Cross-Disciplinary collection, which was 3D printing directly on fabric for the first time. They developed the technology, which is not yet commercially available, but they kind of invited me as a designer to test their technology in an early stage. And so I developed this jacket, which was inspired by the Madagascan sunset butterfly. And I took microscopic images of the butterfly and then turned those pixels and from these little setae, the hairs on the butterfly wing, into an algorithm which can be translating then the image into a geometry. And so what you can see here is directly 3D printed on denim. And it's a quite simple geometry. It's literally just an extrusion of little sticks. But because it's printed directly on a flexible surface underneath, it kind of makes really amazing movements and shows this kind of animalic vision. So moving on from this kind of first experiment with the setae jacket, by the way, the setae jacket was also exhibited in the Designs for Different Futures exhibition in Philadelphia Museum of Art and most recently in the Walker Art Center. And it was a really amazing exhibition. It's unfortunate it's over, but it showcased a lot of really innovative new kind of projects. Maybe some of you have been and seen it. But I developed this kind of technique with the 3D printing on the fabric further in a 9 months research, which was funded by the Horizon 2020 European grant. And it was a research in Austria where I collaborated with a variety of different technology partners. One of them Stratasys, Profactor, Haratech, and the University of Linz. And in this research, I wanted to see, well, with the setae jacket, I still based the kind of idea on traditional cutting pattern. But I thought, well, if I'm actually 3D printing the geometry and the pattern on it, couldn't I also 3D print fasteners onto the fabric? And so I did a lot of research on various different fabrics, what I can print on. This is just a small section. I tested at least 50 to 100 different fabrics. They all worked really well, surprisingly. And I also tested different geometries. And so I came up with this idea that one could do a 3D scan. There are 3D body scanners which can already scan your body in less than 30 seconds. It's something I didn't know before about and was really fascinating for me to explore. So I did a lot of 3D scans of mannequins and models. And then I developed three-dimensionally a cutting pattern which was based on the human anatomy. which moves away from traditional cutting methods. And I looked into how can you optimize those so that you can optimize the digital process, meaning you have a 3D body scan and then it automatically adapts the outlines of the cutting pattern. So that's what you see in the upper left graphic here. And then essentially the 3D file adapts to the various different body shapes. So let's say we as humans don't have always symmetrical bodies. Maybe sometimes we have one side larger, one arm longer, and so on. Nothing is perfect. And so essentially the shape and design of the garment can adapt to your different dimensions. And also the buttons essentially have this idea that as you're changing your body over time, sometimes you're thinner, sometimes you gain some weight, that you would be able to adjust your garment depending on how you want to wear it. And you want to wear it larger, smaller, and so on. Essentially eliminating those standard sizes, how we buy and consume wearables today, which come in specific sizes, but maybe some of us are in between sizes, or we have different sizes at different brands. And so the integration of the 3D body scan would essentially eliminate that step. And you could have a totally customized garment. The idea also was to kind of, here you can see a little bit how this is kind of fit to the body, and then would be kind of adjusted based on your 3D scan. But the idea was also, how can you utilize the 3D print for local production and on-demand production? So you no longer have to kind of go to a store, buy your thing, or you order it online and it's being produced on the other side of the world and being shipped to your location, and then you don't like it, you're going to ship it back. There's so much carbon footprint in the fashion industry that I see really an opportunity with the 3D printing that we can have an impact of change, because as long as we have the printing machine locally, we can produce locally and on demand. And that is one of the reasons I focus more and more on in-house production in order to eliminate the outsourcing as well. So the last part of my presentation focuses on many of the collaborations, what I did. And I want to show a little bit more how this kind of collaboration and co-production within the fashion industry and the costume industry is disrupting traditional craftsmanship and empowering innovation by utilizing emergent technologies such as additive manufacturing. And one of the collaborations I did, for example, with Marina Hörmannseder, an Austrian designer for the Berlin Fashion Weeks, was looking at the traditional smocking technique. It's a stitching technique where we looked into how can we translate traditional stitching patterns into a kind of hard shell design. Obviously, I also I'm well known for my collaborations with Iris van Herpen. I have collaborated with her on 3 collections, 3 dresses, and one of them was 2012, one of the first ever 3D printed dresses, the hybrid holism dress. In 2013, the first flexible 3D printed dress, which was the voltage dress, and in 2014, the biopiracy dress. I'm going to walk you now a little bit through those collaborations. And this was printed in a selective laser, in a stereolithography printing process, one of the largest printing processes, where you can imagine a liquid resin is struck by a UV light, similar to the plant-based award trophy, what I showed you earlier. However, this one was printed out of regular resin, and this is the natural color, so it kind of curs over time and gets this honey color through the UV light. This one was a rather rigid 3D print, so you can see it doesn't flow yet so much with the body. It was more like a rigid corset. And And this was showcased at the Paris Haute Couture shows in 2012. And the printing process for this took 7 days for each side. There was a front and a back piece. And in 2012, this was really pushing any boundaries of what can be done computationally. These are some of the renderings, what you can see here, and they are not published anywhere. So that's kind of a unique way to see how complex the geometry is. Actually, I'm wrong. They are published. So in AD magazine, I wrote an article where they are showcased. On the right, you can see here the front and back, and the hinge is even 3D printed. And I kind of always look at it as an architect, kind of in the various different perspectives. And it's beautiful because in the three-dimensional space, you can zoom in, and it kind of doesn't have a scale within the computer. And I really love this kind of idea that in the digital realm, you don't necessarily have a scale. Once you decide to output it and make it tangible and 3D print it, then it gets a scale. This dress was also exhibited at the Metropolitan Museum in New York at the Manus Ex Machina exhibition in 2016. And it was also exhibited at the High Museum and many other places, but it was also part of architecture exhibitions. So this object kind of lived between the architecture and fashion world. And I thought this is really beautiful because having an object which kind of live within these two disciplines is a really fascinating idea. This one was the first flexible 3D printed dress was made with a flexible TPU material in 2013. And you can see here the development of the geometry was looking at this kind of gradient of lines and this kind of lace-like geometry, which was actually coming from the earlier hybrid holism dress, the honey color one, which was the underlying geometrical structure, which we developed then further into this kind of more organic line work. This is how 3D printers look like, which can print with this material. And there's a little video which shows the technology, how this is done. So this is the selective laser sintering technology, where you have a powder and the laser is fusing the particles together. And then it's almost like in an archaeological process where you're taking the parts out at the end and taking the powder away. And this led to a third collaboration with Iris, the biopiracy dress, which was also showcased at the Haute Couture shows in Paris. This was also published in the National Geographic magazine in 2014, next to a 3D printed ear and then 3D printed NASA suit. So it was quite kind of one of the early advancements of what showcased what can be done with this technology. At the show itself, Iris had collaborated with another artist where the models were kind of shrink wrapped live into these plastic bags. It's an artist who does those live shrink wrap installations, and that's where the dress was one of one 3D printed dress out of a collection of I think she had 60 pieces, what she showed there. And it was fascinating to see how far you can push it, because what you saw maybe in the black dress, in the voltage dress, this was printed with 6 pieces, versus this dress was actually many more elements. It had almost 13 parts, which were then hand stitched together, and the kind of holes for the stitching I already integrated into the digital file. So in the 3D file, I already made the holes so we would see where to kind of put it together. And this dress was acquired by the Phoenix Museum of Art, and it also showcased in 2009 in an exhibition those digital renderings as part of the exhibition. In 2015, Chanel and Maison Lesage showcased a really amazing haute couture show, where I'm going to show you a video.
Fashion has to follow everything what's going on in the world. And I like the idea of the most iconic jacket of the 20th century, redone in a technique it was even not possible to imagine that one day such a thing could exist.
So Chanel and Maison Lesage in 2015 realized this collection of 3D printed Chanel suits, where they utilized embroidery techniques to kind of combine traditional craftsmanship with innovative new technology. And this also in 2015 a series of handbags. This leads me to one of the most impactful collaborations I did in my career, Black Panther, in 2018, where I collaborated with costume designer Ruth Carter on the costumes for the Black Panther film. I'm pretty sure most of you have seen it. I'm still going to show the trailer of the film.
I have seen gods fly. I've seen men build weapons that I couldn't even imagine. I've seen aliens drop from the sky.
Yeah.
But I have never seen anything like this. How much more are you hiding?
Hold up. Let's go.
We are home. My son, it is your time.
Show me my respect and bow down.
You get to decide what kind of king you are going to be.
So it was really amazing and fascinating to work with Ruth Carter and her team on these costumes and develop those digitally and 3D print them. And to give you a little bit more behind the scenes story, so Ryan Coogler and Ruth Carter really wanted the regal attire of the Queen Mother, Ramonda, which is seen here by Angela Bassett. They wanted her regal attire to be really showcasing this kind of technology advanced place, this fictive city of Wakanda, and having that kind of idea of technological advancement really embedded in her costumes. And so one of the things what I was told was that I should really like make it look like it cannot be a hand done. So this kind of idea of like the machine being involved in this kind of advancement of materials combined with the traditional Zulu patterns was something which really Ruth wanted to be embedded in the design. And we worked on a multiplicity of costume parts. The crown in black and in white, you can see here a backstage photograph. Main character Chadwick Boseman unfortunately passed away last year, but it was an amazing opportunity to kind of work with the costume design team. I should mention that this was my first film I ever worked on. At the beginning, I didn't even know that I was working on a Marvel film. because when Ruth Carter contacted me, everything was under strict code name, and we kind of developed the costumes without knowing who the character would be. And so the 3D design came in really handy, because once the character was cast, we then knew the dimensions, and we were able to adapt the digital file later on in a very short time, because we were able to change the parameters of the circumference of the head and the shoulder and so on, and adjust it really customized for the character. And this is one of the advantages I spoke about earlier. When you write codes and when you write scripts and work with these generative design methodologies, you have the ability to kind of change the parameters at the later time without remodeling everything from scratch, essentially. Here you can see a rendering of the shoulder mantle. As we progressed in this collaboration, at one point I realized for which production company it was and what the film would be, but I think the overall impact of it I only realized around 2 months before the film started in the cinemas, when the entire pre-sale was sold out, and I was kind of felt like, wow, this is really happening, and this is so great to kind of be part of this. And here you can see the shoulder mantle was produced in several different parts, and how it was put together. It wasn't developed in parts because of the printing constraints. It was more because of time constraints, because we had to produce it quite quickly, and so we had to print the parts in several different machines. I worked with my long-term 3D printing partner in Belgium to get a materialize, who was part also of a lot of the other work I have done before. And I chose them because I had a lot of experience with them over the past 15 years. Now, the last image of the film I want to share with you is this, and maybe you remember from earlier the light design I talked about, the new nature light. So when I went to the cinemas and watched the film, and then there was the lab scene where Princess Shuri is kind of in the middle here, I realized that they had 12 of these lights in the scene, which I had designed with Ross Lovegrove in 2011, so 10 years earlier. And it was really exciting moment to see that, because I had literally no idea that the production designers were putting that into that scene, and that was really exciting to see. Ruth Carter was nominated for the Oscar and asked me to design her a 3D stola within 3 weeks. I had literally time between her nomination and the Oscar event to design her this customized 3D stola. She is the first African-American woman to win this Academy Award in this category. And it was a really fantastic journey to be part of that with her. And we worked with Swarovski on putting crystals onto the 3D stola. It was the fastest piece I've ever made, from 3D scanning Ruth to kind of customize it for her. It wasn't the first project I did with Swarovski. I had done a collaboration with them earlier, 2018, where I looked into the early stages of 3D printing with glass with them. And we looked into the development of their technology in-house for the opening of their new manufacture. Swarovski is an Austrian company. Their headquarters are in Wattens and surrounded by glaciers. And so the project is called Crystal Glaciers, and kind of should showcase the possibility of mass customization and generative design within this kind of technology. The last part, which I'm going to go just quite quickly through, is this kind of way of collaboration and co-production, and the way of how I work with these brands and with these partners is something I also bring into the teaching. At UCLA, I was fortunate to teach with Greg Lynn for 4 years the postgraduate program in the architecture department, where we focused mainly on the robotics technology. And I utilized in various different technology seminars with the students robotic 3D scanning or innovative new processes like rotomolding on the robots to create form, which is kind of taking traditional methods and then combining it with robotic motion. I work with students on robotic fabric casting and kind of implementation on assembly structures, 3D printing with clay. Those are all mostly independent studies and research, what I'm doing at UCLA. I most recently got some funding to do a project from the Department of Architecture on robotic timber assembly. So this kind of idea of automated assembly and implementation of robotics with CLT or wooden slats and assembly of cellular systems. And besides that, the last 5 to 6 years I've been teaching in the MArch program, where I teach design studios with architecture students and introductory design courses. I also teach introduction to computational design, advanced building construction classes, and really focus much more on the architecture in my teaching and academic research rather than in my professional practice and research. I focus more on a smaller scale, simply also because certain technologies are not yet existing on a larger scale, and only very recently we have seen more and more opportunities within a larger scale for digital fabrication within architecture, such as large-scale 3D printing with concrete, for example. To close the lecture, I just want to also mention I'm directing the summer programs, and we have 2 very exciting programs coming up in July. One is the Jumpstart, a 4 weeks program for high school students and college, and Teen Arc Studio, which is for teenagers between the age of 14 and older. And in these 2 architecture programs, we're going to focus on kind of the early aspiration of architecture and design. And with that, thank you so much for joining this lecture today. And I'm really excited to share my work with you, and look forward to all the Q&A.
Hi, folks. I don't know whether you can you see me or hear me? I can't see myself here.
Yes, I can see you.
You can, but you can't see me. That's probably a better thing, because I'm sitting here with my mouth agape. I said it was going to be stunning, and gosh, we were indeed stunned. So I think you're getting rounds of applause in the chat section. I'm applauding. Thank you so much, Julia. Just completely inspiring. Absolutely stunning. So, Julia, we don't have a great deal of time, but I was wondering, would you be willing to field some questions? It's probably about 3 in the morning in Jordan, but maybe you've still got some headspace, because we've got a ton of questions.
All right. Okay, let's do it.
Great. So I'm not going to be able to get to all of them, but I would like to thank the audience, especially students, for submitting some of the best questions I think I've seen at the end of a talk. And I wondered if we could maybe gather them together. Apologies, folks, if we don't get to your question. We probably won't, but maybe if we gather it together into like groups of questions so that we hit each thing that people are asking about. You know, one of them is the question of breadth. So, for example, one of the first questions we had was from Andrea. Did you find it hard changing focuses and media over the course of your career? And my colleague, James, as well, said, you know, the work is almost too inspiring. It could be daunting for students just emerging as designers. Do you have any kind of advice for how to approach that?
Yeah, I think one advice I have is that often you have something in your mind, or you have an idea what you want to do, and then you really want to pursue that, but you realize that it's not that easy, or you realize that there are challenges what you're facing along the way. And so I just want to suggest that you don't get kind of pulled away by those challenges, but rather embrace those challenges, because those challenges will guide you in the right direction. Meaning, for example, if I may share one challenge I faced is when I was 18 years old, I was really interested in fashion and architecture. But there was no program existing which kind of focused on both, especially in Austria. Everything is so much in categories. Fashion, architecture, product design is all so different. And so I applied to the University of Applied Arts for fashion design, to the studio of Raf Simons, and I really wanted to study there. And I didn't get into the program. And so it was like the same day I took the train and went to University of Technology and signed up for architecture, because that was equally interesting to me. And I was like, okay, this is fate. I'm going to start studying architecture. And I started with 500 other students and very quickly realized, wow, public university, 500 students, I've really got to be, I really got to specialize myself to kind of be able to achieve my goals. And so I actually studied for 8 years. So it was really long time. And I studied at various different institutions. And I had no idea that 10 years later, I would get the opportunity to work with haute couture houses on fashion projects. Today, I know that if I wouldn't have studied architecture, I would have never gained those kind of skill set to 3D model and to be relevant to the fashion industry. And I was actually able to do those collaborations, I think, only because I went that route. If I would have done traditional fashion design, I might have not been able to do this. In the last 10 years, a lot of things have changed, and today there are programs available where you can learn all these techniques equally in other programs as well. But that is just a story, what I can share, that it kind of, I did a huge circle to end up where I anyway wanted to be. And I think sometimes you just have to go with what happens, and eventually it will make a closure of the circle.
Yeah, that's fantastic. So your career too is sort of organic, a bit like the design. But what maybe students can be taken from that is the realization that careers aren't linear. Like, we can be looking at your work now, and it's just like you can be stunned as to how you ever get there. And the story is complicated and you know, open to some sort of chance. And you know, we've got another set of questions, and there's a ton I could have asked you here about the material properties and the process of your work. Oh, look, I think I might have popped back there. I could pull one out here for you from Michaela, and apologies, folks, if I mispronounce names. But this is a typical one. Michaela says, is there a natural element you would like to utilize in fashion or any other design through 3D printing that you've not tried so far?
Yes, I would really love to explore 3D printing with natural fibers, and that's simply not yet. I haven't come across any process where you can do that. I've seen you can print with carbon fiber, and you can print with some more like rigid fibers, but I don't think there's anything out there where you can print with like cotton or natural fibers, because there's always the heating process involved. And so I think something where we could, the closest we come to that is kind of with 3D knitting perhaps, but it's a different process than the printing. And that is something I would really like to explore, and look forward for some researchers to develop some processes with that.
Fantastic. I'm going to move to another set of, oh, hold on, though this was really interesting. Actually, maybe I can do this one as well then. We're gathering things here under material properties and processes. So if I was to try something else here, this is from Zach. What software do you use for your 3D modeling, and how do you go about networking? Because it seems like you have been able to collaborate with lots of other amazing creators.
So I use architectural 3D modeling softwares such as Rhino. I use a lot of Grasshopper, which is a generative design plugin for Rhino. I also use Polygon mesh modeling softwares, and really use a lot of open source softwares as well. I kind of don't have one specific one I work with. I kind of really always look what's most applicable. But yeah, Rhino and Grasshopper would be the main ones. And then I kind of look what's needed in the research project, which I showed with the fabric, where I mapped it onto the body. I also worked with CLO, with CLO software. And it's always different.
Now, we've got a bunch of questions around sustainability, costs, and equity. That's a little category that I'm creating here. And these are questions from people like there's Jazzy, Muriel, Yang, Lily. I'm going to make I'm going to try and mush these up into a composite question. Muriel, happy Earth Day. I love how you take inspiration from nature. With the job that you do, how do you keep your design sustainable and safe for the earth? And if I can just sort of tack on other things there, sustainable products, this is from Lily, have more care put into the quality, but it can mean that prices can be much higher. As a student without much financial flexibility, are there ways we can practice sustainability in our work? Similar sort of questions there about costs, quality from Yang, Jazzy, to wondering like, would it be one day possible to mass produce work more efficiently, more cost effectively? So as I say, questions there about sustainability and equity, and well timed for round about now.
That's a really great question, and one I get a lot, and maybe something I don't talk so much in the presentation, but more in Q&A sessions. So you saw how I built up my presentation also. A lot of the early parts was kind of university things, what I showed, research, and then I showed a large majority of work, which was my own research. Now, you might wonder, how do I fund this, right? I don't come from a rich background. My kind of resources are limited. So I look a lot at these kind of collaborative projects with brands, also as a kind of way to then fund my own research projects. Or I look at grants, which are either from Europe or from the US, or less from the US, more from Europe, where which help me to fund some of these research projects. And then the other source I find is that I collaborate with great innovative 3D printing companies. And so I was both lucky, but also really hardworking to kind of put myself on the forefront of this technology, so that I got 3D printing companies approaching actually me, asking me, hey, we have this new technology, would you like to try something with it? And so when you become so specialized in a niche where there aren't yet many other people, then you get these kind of opportunities. That also means that you have to put a lot of time. There's not necessarily money what you get through that, but you get the opportunity to test new technologies, to make a project with that, which you then can utilize to maybe win another project again with it. And so there isn't necessarily a linear route of, I would say, methods. It's kind of a diversity of different projects. Or in terms of equity, I would also like to say that one thing what was really great about Black Panther was that it was one of the first projects which had a reach which was so broad that it wasn't only limited to a closed circle like the haute couture. I mean, there's only a limited amount of people who can go to a haute couture show in Paris. But there is obviously now with the pandemic, this has changed a bit because everything is more virtual. But the Black Panther film had really had an impact because it was, everyone could go to the cinema or watch the film at home, and it was, therefore the reach to the public was much broader. And I had friends in Austria who never really understood what I actually was doing, reaching out to me and said, "Hey, Julia, I finally know what you're doing," even though that wasn't necessarily what I always do. So that was really nice, that the kind of working with the costume industry gave me the ability to have a broader reach and reach more people to show what this technology can do. Yeah, and then towards the sustainability, as you can see, I shared a lot of ongoing projects at the beginning of the lecture, where I'm really focusing more on how can we implement the sustainability aspect of the materials. The JK jacket, which is also in the background here, that one was printed entirely without support material. And so I had to kind of sacrifice on the complexity of the geometry and just do those little sticks which are possible to print without support material. But at the same time, eliminated any waste material. And then I looked at printing it on natural fibers so that you can kind of reduce the water consumption. And if you think of that as how we could implement that on a mass customized way or mass production, we could bring down the cost of that also. Right now, it's still a non-commercial technology and it's really expensive because not a lot of people are utilizing it yet. But I see opportunities with what we see with the in-house printing. Like you can by now buy a 3D printer for less than $200. That was impossible 15 years ago. That was just not existing. And so we can see that there's a lot of change coming. It just takes time, but there is a lot of resources. A lot of universities now have 3D printers. There are fab labs where you can go to print your ideas. So it seems the technology is much more embedded now within and more accessible than it was some years ago.
I think we've got hopefully time for maybe one or two other questions. We're going to be wrapping up in 5 minutes, and it would be nice as well if we can leave just a little time to see if we can hear the Chancellor's introduction. So it'll be an outro instead of an intro. Just to loop back to Black Panther for a moment, you talked a moment ago about that, and it was a collaborative work. This was from a question from Candice. Did you draw inspiration for the Black Panther costumes from existing cultures? If so, how did you conduct your research? Maybe there's a possibility of thinking there about the collaboration.
Yes, so I got everything from Ruth Carter. So I got like a book which was about African illustrations, and I looked at traditional Zulu patterns, and then kind of took those took those illustrations and translated them into 3D, just as an initial starting point for the design. And I think the costume department on their end did a really long research into those patterns, and that was all done by Marvel and by Ruth Carter. So my part really was, I think I worked with them around 3 to 4 months, and in that process I was literally given the kind of patterns they wanted to work with already. So I wasn't that much involved on the initial research of those geometries and designs, but more on the kind of applications and implementation.
I'm going to do a fun closer if I can. This was from Kelly. What do you like to do when you aren't working on these projects? Or what do you do while you wait for the columns or your projects to finish printing?
That's a really great question. So I really like to be out in nature, and I also like to sometimes not do anything, because I have this kind of phases where I work really late and really long hours and do a lot of things. but sometimes I also just like to relax, and I also like to travel, and I have to travel a lot due to a lot of these projects. And so, I like to spend my time with family and friends, and but I'm more like an outdoor person. I like to go to the beach in LA. I like to, do regular things. I like barbecues, and yeah. Right now I'm in Jordan at the Dead Sea, and I'm looking at salt crystallizations. I found some nice objects today on the beach.
Wow.
And so I take every opportunity to look at what nature and what Earth can give us. And so maybe that's a great way to close this lecture on Earth Day.
It's an absolute gift. That's perfect. So what I think we'll do then is thank you once again. Spectacular and inspiring, wonderful talk.